Well, hello everybody, and welcome back to HVAC training videos. Hope you guys are doing well. I just want Eric to know he can't speak right now. But whenever I told you before the show, Eric, that I always had like this last minute thing where I wouldn't hit the button, I just remembered to hit the button. So I just wanted you to know that. Every single time. It's going now. This will be a podcast later. Well, let me rephrase that. It will be a high quality audio podcast later instead of something I rip off of YouTube like a third grader. So that's the good news. Welcome back, everybody. Looking down at the chat here, we have our friend Darth Schrader. It's awesome. Susie, what's up? Jessica Egan just got home after a long day. Hey, this is the perfect way. Do HVAC for 12 hours and then watch it on YouTube for another however long this lasts. I respect the work ethic. We have Toolman for HVAC says, Zach, don't work Eric over too hard. It's like I'm a loan shark. He owes me money or something right there. I'm going to hit him with a stick. I promise I won't. He knows more than I do, so I won't be able to. Let's see, who else do we have here? I'll scroll up. Eric's actually in the chat there. I see you there. And we have Clint Glasgow. What's up, Clint? Big supporter of the show. The HVAC Grapevine. This better be good. Challenge accepted. All right, we'll see what happens. And then Steve, Residential Basics. What's happening, Steve? It's good to see you here. We're all going to be learning our tails off tonight. The reason why it started late is because Eric and I were just having great conversations about stuff that had nothing to do with the show. We were just talking about ductwork and friction rate and the Bosch and all sorts of stuff. It was just a lot of fun. And I'm just going to be honest with you. We just kept talking because we were having a good time, and that's why the show's late. I got to be honest with you guys. That's what was going on. All right, so I'll make this really, really quick here. Live notifications. If you want to be texted before we go live, there is a link in the description of this video. You can just click on that. It's a little Google Doc. You just fill it out, and we will text you. And then you will never be late, ever again. Probably. because I was late tonight, and I'm in charge of this. So if you ever want to play Skill Trade Up on Wednesday night, it is a live stream as well. We do HVAC trivia, and we give away tools. That is pretty much the pinnacle of watching online HVAC. I'm going to tell you right now. It's a lot of fun. We get like 4 or 5 guys at the same time competing against each other doing HVAC trivia. It's awesome. And it's awesome for multiple reasons, because we got all the questions there we can learn from. We are battling internets of different latencies. You know, one guy has a 2-second lag, one guy has a 4-second lag. It's just a balancing act every week. It's a lot of fun. If you want to listen to podcasts, boy, we got you covered. We got the HVAC Shop Talk podcast. Every week thereabouts, you'll have a podcast. This show right here will be a podcast, most likely next week or the following week. I'm also editing a podcast. I brought Tersh back. Many of you were there when our Tersh show got cut off midway with family crisis, so I brought him back and interviewed him separately. So that will be coming up in the next couple weeks as well. That was a podcast called Surviving the Winter. And we talk about how your HVAC company doesn't have to struggle so much in the wintertime. Planning ahead pays off a whole lot. And actually, it depends a lot on your employees, turns out. So Tersh is a smart guy that way. All right, here's what we're going to do. And I want to go back to the chat. We have Randy. What's up, Randy? Old Handy Luke. Old Handy Luke. Guys, don't be fooled. He's 17. He's not old, but he is handy. We have T. Leck. I keep thinking that Lek is supposed to be tech for some reason, because I think there's a total tech out there. There's all sorts of tech names out there. It gets confusing. We still love you. Thanks for coming. All right, I'm going to play a little ad here. Our buddies at EWC, we're actually talking about zoning, too, before the show. That's why this takes so long to get started, guys. We just have too much fun. So we got a little EWC commercial right here. Then Eric and I will be back after this. We're going to talk about defrost cycles. Oh, man, it's going to be a whole lot of fun. We'll see you on the flip side, guys. The best forced air zoning controls in the HVAC industry come from EWC Controls. This includes the Workhorse BM Plus 3000 zone panel, 3 zones, multiple dip switches so you can customize the controls to your particular system install. Another workhorse of the system is the URD and ND dampers. These power open, power closed dampers are both reliable and long lasting. So for the entire life of your system, you won't be replacing your zoning components. And lastly, the innovative SBD2 static pressure bypass with the wireless NFC interface take this whole thing to a new level of precision and reliability, because you can set your system right there at your fingertips to the particular static pressure you need. No more guesswork, no more barometric arms. Go to EWC Controls Incorporated. You can find them online to learn more, and look for them in your local supply house. All right, that was a lot of fun right there, EWC, man. Eric, welcome to the show for the first time live.
Thanks, Zach. Glad to be here. A lot of fun, huh?
So what's it like live? Do you prefer live stuff, pre-recorded stuff? Have you ever done the live thing before?
You know, I haven't done a live thing before like this. Probably about the only thing live I've done is, training just for people. But heck, this is going all over the world, right?
This is going to 7 different countries. According to my analytics, that's United States, Mexico. I'm just making this up. I don't know if it leaves the country or not. I don't even know if we get out of North Carolina, to be honest with you.
Well,
you could probably go outside and shout defrost stuff louder than this will reach as far as distance.
Somebody said they were on there from Northern Indiana. Who is it? Who was that?
Northern Indiana. Who? Okay, let's find this person.
It was Toolman for HVAC. Was that it?
They mentioned heat pumps. Yep, Toolman for HVAC. What's a heat pump? I don't need no heat pump. Hello from Northern Indiana.
So he's just a little north of me, because I'm in Central Indiana.
Well, there you go. So what system do you have on your house? We should preface this here.
So I have a way big oversized air conditioner and a hugely oversized gas furnace at the moment.
Now, did you size those?
No.
All right, well, that's a critical part of it. Okay.
It came with the house when we purchased it, and we're in the middle of remodeling, and that's going to go away, and then I will be putting a heat pump in.
Oh, so Nate Adams is actually going to come to your house?
Probably, yeah. I'm going to have him come down here and commission it for me.
Oh, that would be awesome. That would be actually that'd be really cool if that happened. So, Eric, let's break the ice with everybody here. Tell us a little bit about yourself, what I like to call the 2 minutes life story. Once you get past 2 minutes, I will harp on you to stop. So try to, keep it in 2 minutes.
Just cut me off when you're done. Just blank me out.
I will remove you from the show for like a 5-second period. It's like, all right, Eric, we agreed on 2 minutes. And then I'll bring you back and you'll just be shouting at me probably.
So I'm about, when did I get into the trade? About 2000 or 2004, I guess I started in the trade. Have worked in residential installation, service tech. Actually, I started out as a service tech and then went into replacement installation and then was a service tech and then went into commercial and industrial as a service tech. Worked for a distributor for a while as a technical support and training, and worked as a trainer for a rep company for a while. And now I own my own company and do custom training and make training programs for places, as well as consult with homeowners on severe comfort and health issues in their houses and try to help them find a path to get those fixed.
Nice. Okay, you have 42 seconds left.
Wow.
What kind of music do you listen to?
You name it, pretty much anything except like super deep classical and like maybe really, really hard rap.
Oh, that's pretty diverse. I mean, I will tell you that while I work today and yesterday, I listened to The Four Seasons by Vivaldi. So, I mean, we differ there.
You're over my head on that one.
That dun, 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 dun. Everybody knows that one. I'm sorry. I won't talk again for the rest of the show. That was bad.
Now let's not have that. I got to have somebody to help me out here, because otherwise I'm going to be lost.
Well, all right, let's get down to the subject at hand, which was we're going to talk about defrost. And I realized whenever I was kind of asking, I was trying to find a person to talk about defrost, and you said, yeah, I can do it. And I realized that you must have a pretty wide skill set as far as understanding HVAC concepts, because we've been all over the place so far. We've done vacuum, we've done recovery, and now we're doing defrost. I mean, what's going to be next? Oil heating? Can we do that too?
You know what? There's one thing I know about oil heating, and that's that it stinks a lot when you get done working on it. Or I did, right? I can count the number of oil systems I've worked on both hands.
Oh,
I mean,
that's a good thing.
I've worked on a few. I know enough about them now to say, no, I don't want to work on those.
I think you're a smart guy. And I think that's everybody that I've had this sort of conversation with is like, do you know this? You know this? And I said, do you know oil? And everybody's the same look on their face. Like, there's like, no, I don't want to do oil. I don't want to do oil. But
I know enough about oil to be really dangerous. And I've actually read a bit about it just so I know enough about it if I ever had to come on it. I've worked on some, but am I an expert at oil? I don't even consider myself an amateur at oil.
Okay. Well, we're not going to talk about oil, so that works out perfectly for today. We're going to talk about the opposite of oil, which is a heat pump. I don't know how that works, but it seems like the opposite. So we're talking about defrost today. So let's start with our very first question of the day, which is, why does a heat pump have to defrost? Let's start the conversation there. And maybe get into, let's start with why does it have to defrost? Because we have this heat pump giving you heat in the wintertime and typically warmer climates, relatively. So why would you have to defrost it?
Well, heat pump, first off, it reverses its cycle to transfer heat from outside to inside in the wintertime, right? So in the wintertime, we have to have the outdoor coil colder than the outdoor temperature in order to gather heat. And when it's colder than the outdoor temperature, a lot of times it's below the freezing point of water. So it builds up, it's going to collect that frost on the coil. And if we don't periodically get that frost off the coil, it turns into a block of ice and we don't get any airflow, so we can't gather any heat.
That makes a whole lot of sense. So you have a coil that's just breaking it down here. You have a certain temperature in there, and it could be in the 40s, but you could have a coil that's below 32 degrees and causing those condensation droplets to freeze.
Yeah, because you've got moisture in the air pretty much all the time. And if it's a humid climate in the 40s, and even 30 air temperature, when you have a lot of humidity in the air, that's honestly the most common times to see a lot of defrost needed.
Absolutely.
because
We had that problem here. I mean, I'm looking over here now. It's too warm out now. It's 62 degrees outside, but our relative humidity is 99%. And that's pretty common for us even in the winter. That's why we don't have humidifiers on our systems, because it's pretty humid still here.
better turn a dehumidifier on all winter with
Yeah,
that.
this house needs a dehumidifier, but that's a story for a different day. I won't get into that. It was 65% today in this house, relative humidity. Oh my
That's
gosh.
sticky.
It's not the lowest it's been. It's been well into the 70s, and it
Yeesh.
feels horrible. And I like to think I know what I'm doing, but that's neither here nor there. So, okay, we've established that a heat pump needs to defrost. So, taking your standard heat pump, let's start with the bare bones. You got like a 14 SEER, 15 SEER heat pump split system. What is the order of operations, sequence of operations for typical defrost? And we kind of break it down by piece.
So let's just say typical order of operations, and we'll talk about some of the nuances, I guess, a little bit later here. But typical order of operations are the outdoor unit has a control board in it. It's going to decide, that outdoor unit is going to decide, or the control board is going to decide. There you go. Got a good picture of one up there. That the unit needs to go into defrost. And there's a couple different things that can happen, but basically it's going to shift the reversing valve and switch it from heating mode back into cooling mode, so that we have the refrigerant flowing and switch the indoor coil back into an evaporator, and make the outdoor coil a condenser. It's going to have typically a W terminal on the outdoor board, which then turns on the heat indoors so that we don't get cold blow and things like that indoors. It's going to run it for a long enough period to warm the coil up. And typically they look at coil temperature, the outdoor coil temperature, and termination then is done when that outdoor coil hits a certain temperature, at which time it switches back into heating mode and goes back to heating with the heat pump.
Well, that was beautifully done. Okay. So we have a system that's running in heat. And I think everybody has seen this. And just to put like some visuals with this, if you've ever worked on a heat pump before, there's usually two things I would see. You would see a heat pump that actually shut off, because sometimes we'll have like a dead period that allow the refrigerant to equalize for a minute. So it doesn't sound like the ones that don't have that sound whenever they shift into defrost, which is what I call the Goodman sound.
So that's your quiet shift. Or, what it does is it turns the compressor off to shift the reversing valve, because you still need to have pressure differential in there to shift that reversing valve, right? Your reversing valves are a pilot activated valve, which means that solenoid on there only shifts a pilot valve, and then the differential refrigerant pressure is actually what pushes that slide across inside the valve.
I don't have the opened up valve, but
right.
You can see that pilot valve on top of the reversing valve right there, causing that shift.
Yep. So it shifts the pressure from one end of the slide inside the large tube to the other end, and causes that tube to slide back and forth inside there to shift the direction. Now, if you're looking at the top tube, which that one's kind of odd. I don't think I've ever seen or remember seeing an offset.
This is Train American Standard ones right here, the ones that are on the side access.
Yeah. Interesting. I don't remember seeing that on those, but hey, maybe they were and I just never caught it. But normally your top single one should be your discharge on your compressor. And then your middle one on the bottom side there is going to be your true suction, or always your suction. And the other two lines switch.
And that's where one of them is going to be your hot gas line going to wherever it's going to go, depending on where it's switching to.
One of them's going to be your discharge line, so that's either going to the indoor coil or the outdoor coil, depending on how it reverses itself, because it flip-flops the two coils between evaporator and condenser modes.
Let's break that down real quick, because that's actually going to be one of the questions we do on our Skill Trade Up trivia show there. All right, so when you have an air conditioner running an air conditioning, you have a condenser outside and evaporator inside. And when you have a heat pump running in heating mode, what you're saying is that there's a condenser inside and evaporator outside.
Correct, yes.
So you're just rejecting the heat into the space instead of rejecting it outdoors, basically.
Right. A lot of people will have looked at me over the years, and I kind of did it first when I started learning about heat pumps, and I was like, wait a minute, there's not much heat outside. How are we getting heat outside? And then I thought about it, and I'm like, no, because in the summertime, it's cooler in the house than it is outside, and we transfer heat from the house to outside. That's what the vapor compression cycle of refrigerant does.
That's absolutely right. And, I thought the same thing. And then, we go to science class in school, and they're telling you about absolute zero. It's like, well, that's a long way from 30 degrees outside or 20 degrees out. There's a lot of heat out there. But just because you feel cold, you assume that there's no heat left, I think is the idea.
I equate it to two different things. There's scientific cold, which is technically anything above absolute zero has heat in it. And that's what science tells us still has heat quantity out there. And then there's human cold. And humans like, right around that 68 to 72 degree range, 75 maybe, we think that's really comfortable. And as it goes hotter, we think it's hot. And as it gets colder, we think it's cold. So we like to I guess, project ourselves onto the environment around us and think that just because we think it's cold means there's no heat there.
It's actually, science says human cold is around 68 degrees or less, and mother-in-law cold is 80 degrees or less. That's from experience. She's right over there right now.
It looks like a curtain hanging there. Is she going to come through that wall?
No, she's not the curtain. She's not that pale. No, she's in the other room, I'm sure, watching some sort of show on A&E that deals with somebody being caught for murder. I can say that 100% of the time, and that's just the way she rolls. People have their favorite shows, and that's what hers is. But she's like that too. I mean, it's just a perception thing. It's just kind of a joke I was making. So we have our condenser and evaporator flip-flop, and then, of course, when it goes in defrost, it's turning back into air conditioning, so they're flip-flopping back over again, right?
Right. So we got to flip-flop it. In defrost, we flip-flop it back to a cooling mode where it's pulling some heat out of the house, putting it into that outdoor coil to melt that ice and turn that ice or frost into liquid so that it runs off the coil.
And let's go ahead and mention, I know I put it farther down in my notes here, but the fan turning off, the outdoor fan or condenser fan turning off during the defrost cycle. Why is that an important part of defrost?
Well, because we don't want to take that heat. And normally when we're in cooling mode, we're blowing air across that to get the heat away from the coil. Well, in this case, we don't want to take the heat away from the coil. We just want to transfer it into the ice that's on the coil. So it's using conductance rather than convection to get the heat away.
And something I've noticed in my long and stellar service career is that there will be periodically defrost boards that fail. The machine will defrost, but the fan will run during defrost, like either the relay's stuck. I see a lot of train units that would do that, and they would still defrost because you still had a little bit of heat put out, but the defrost cycle would vary in length.
Take much longer to defrost that. Yes,
The
idea with a defrost cycle is to get it done and get it back into heating mode as quick as possible.
Absolutely, because one of the other things that's running is your heat strips or supplemental heat or whatever you want to call them, resistance heat. Now, kind of describe why that happens.
If you have an air handler, you're going to run resistance heat. If you're using a dual fuel, of course, you're going to run the gas furnace in there. Typically we turn on the resistance heat on the inside, and it's designed to reduce cold blow on the occupants so that we don't have a real cool air coming out, because we're in cooling mode. We're taking heat out of that, and we're going to leave the fan on indoors to bring some more heat into the coil. Now that's on a typical, split system. And in a package unit, we're going to leave that fan running to bring some heat into that coil so that we have heat available to transfer into the outdoors and we don't start freezing up. Well, you're probably not going to freeze up the indoor coil because your dew point should be too low, unless, of course, you live in Zach's house and the humidity is, I don't know what dew point there.
The dew point's probably about 70. Here. I don't know. Whatever the temperature is, just a little less than that. That's where our dew point is.
You got to get that fixed, buddy.
I know. I'm working on it. Trust me, I'm going to build a contraption. My issue is that the existing contraption should handle it, but I'm going to, by the time it's all said and done, be 15 relays up there, and it'll be 55% relative humidity at the maximum.
We can talk about that. I might be able to help you.
I would like to, we can brainstorm over that one. We got a question here. I don't think it doesn't really relate to defrost, but I'm gonna stop here because we'll forget about it later says, why do heat pumps have charge compensators and some don't? Now, my feeling on this, and I don't know how much you know about this, is that it was because there's a required charge difference between cooling and heating, and you had to have a charge compensator.
So it's going to have to do with the physical difference in the coil sizes. So
that makes sense. Okay.
The coil, some of your indoor coils or your outdoor coils, they're going to hold different volumes of refrigerant. And because we're flip-flopping the two coils, right, the coil will hold different volumes of refrigerant. So we may need to have that charge compensator to move a little bit of charge into or out of, depending on how the coils are sized in relation to each other.
So maybe like a storage tank will be a simplified version of that.
That's pretty much what it is, yeah.
Now, where I've seen this happen, this goes right along with what you're saying, and that people are wondering like where you see these things. I know that I've seen certain Goodman high-efficiency heat pumps with charge compensators, microchannel coils, which are the only microchannel coil. Like you have a microchannel coil on an outdoor heat pump, but the indoors tube and fin, you'll see a charge compensator. Older ream units used to have the one with a double coil back in the day.
Even a lot of the new ream units have charge compensators.
So they still have them. So you see them current day. Is that that's the only one I could think of that's relatively modern, unless you can think of another one.
There's a couple different ways you can do charge compensation. And I mean, that's really going to go down into the weeds.
It's a whole nother show is what you're saying. Charge compensation, January 2021. We will revisit that, but that's the general idea, is the storage of the refrigerant, because
basically it takes some liquid refrigerant in, and what they do is the charge compensators, at least the ones that I'm used to, they are a shell that goes around the vapor line, and there's the vapor line goes through the middle of them, and then the liquid line comes up, and it allows some of that liquid to go up into the shell, and the heat from that vapor line, depending on which it is, either pushes it out or kind of draws that into that shell a little bit.
That's exactly how I understand it too. That's the Goodman ones. We were really, because we sold Goodman for a long time. Don't hold me to any low standard there.
But Goodman's a good. I mean, it's actually a pretty decent brand if it gets installed right. They get a bad rap because they unfortunately sell to anybody that walks in off the street and on the internet and everything.
You talk about their dealer program? No, we saw them a lot. Why I remember them is because the liquid line, where it hits the shell of that device, some of the units in particular had a bad run of high vibration, and they would break that line off, and it would be a spectacular event.
Oh,
and then somebody might change that and come back the next day because the same thing happened. I'm just saying, it might have happened.
We won't talk about that.
Then somebody's dad will be made to get a new unit and yell at Johnstein, and that's the end of that story. But no, that's really my experience with them. I see them every now and then, or I saw them every now and then. But that's not defrost, so we're heading back to defrost. And we were on the heat strips of defrost. One of the questions I had for you, I wanted to ask you, was the fact that you had to run those heat strips for at least a couple minutes or so. And I guess most terminations are cut off at about 10 minutes, as long as defrost can be. And you can confirm that too. Does it not make the heat pump a lot less efficient than having like a gas furnace, like a natural gas furnace or something like that?
Well, I mean, you're going to use more energy to heat the house. It really doesn't change the efficiency of the heat pump per se, because you're just using a different source to heat the house. But yeah, it's going to cost more if you run those electric heat strips. And if you talk to, there's a couple schools of thought. Most people and most of us turn on the heat strips in defrost mode. But if you talk to somebody like, say, Nate Adams, and who does a lot of really well-sized, high-performance, what I consider pretty high-performance houses in normal housing stock. He does a lot of retrofits in houses. And he does not turn on the heat strips on his heat pumps. And he chases a lot of really, really high-quality comfort in his houses, and he also chases some decent energy efficiency in the houses. And he's found that it saves quite a bit of money over the year. And if you turn them off, he hasn't had customer complaints about it.
I had, speaking of this whole idea, I was forced to do this sort of situation one time when I got into a mess where I didn't have enough wiring as far as thermostat control wiring, and I couldn't run a new wire for where I was at. And at the time, I hadn't had the brainstorm that I had since then, which is I realized that I could run the heat pump with 2 wires if I put some relays in there. So it never had heat strips, and I never heard from them about the defrost cycle, which kind of surprised me. I said, well, let me see, because, I don't know that one-to-one mini splits they don't have heat strips in them. So I was thinking that, is that along the same principle where they don't really need them? Maybe my climate doesn't really need them. Do you know what I'm saying? That like a single head mini split doesn't have heat strips in it, but it has a defrost.
Right, but the single head mini splits are a little bit different animal because of how much control they have over the indoor fan speed. Because if you watch when one of those goes into defrost, they're going to turn that fan speed down to virtually nothing. It's just basically going to trickle air across that indoor coil while they're defrosting on the outdoors too. And that's the reason for it, is to help reduce that cold blow.
Does that hurt defrost at all, or make it longer to have that really low suction temperature and pressure going through the coil?
Well, I mean, your outdoor coil, of course, is going to be discharge, and your indoor coil is going to be your evaporator. So you got low pressure. It really doesn't hurt anything. And again, the mini splits, they have a lot more control over things because they're constantly looking at the indoor coil temperature, the compressor speed. If they've got an electronic expansion valve, they're looking at that expansion valve temperature. So they can really modulate every little thing, and they can change that indoor fan speed every little bit to do exactly what they want to do.
So just since we're talking about mini splits, do they keep the same sequence of operations minus the heat strips?
Generally, the one thing that's different on your mini splits is they're typically, at least in the cold temperature units, your low temperature units, they're going to have base pan heaters in them to help keep any ice from freezing on the bottom of them. But yeah, and they probably won't turn the compressor totally off for a quiet shift. What they will probably do is ramp that compressor down really low so that they still have a little bit of pressure differential being built on that by the compressor, make that shift, and then jack the compressor speed way up. And by jacking that compressor speed way up, they're going to get that compression ratio way high, which means that they're going to get the outdoor coil hot faster, of course, which means a faster defrost cycle.
Before I go, I'm going to ask you a question about quiet shift. Now, you sent me the picture that I downloaded right before the show started, and you're kind of talking about ice at the bottom of the coil, so I'm going to put this up, and you kind of give us the play-by-play for what caused this.
So that is what happens when you don't get the water away from the bottom of the coil. It will crush the tubes on the bottom of that coil. It will turn them into a U shape from a round tube. And typical heat pumps in my climate here where we have snow, we've got to put them up on legs to get them away from that snow and make sure that we don't get a refreeze on the bottom row of that coil. And if you walk up to a heat pump and you start seeing ice, just solid clear ice built up on the bottom of that coil, you've got a problem that you need to get corrected. Now, when you get into things like VRF, mini splits, things like that, they have base pan heaters, and some of them even have coil heaters on the very bottom of the coil to be able to ensure that you don't get that ice built up on the bottom rows.
I know a couple heat pumps that could have used that over the years, unitary brand heat pumps, but they had issues beyond that. I wanted to ask you about quiet shift, since we just talked about that. Now, quiet shift, like we were saying, is a period of shutdown on the compressor before the defrost cycle starts. So, and actually, I think it shut down on the way out of defrost too.
It's right before the shift in the reversing valve, either direction.
Okay.
Because otherwise, you get almost like a grinding noise in that compressor right as the valve shifts.
Absolutely. I can do a great impression of that noise. It is blah. And that sounds ridiculous, good. But that's it right there.
Yeah, that's actually really good.
Those of you guys who don't know about heat pumps, I just killed that impression. I just want you to know.
And about that time, you get the phone call that says, my outdoor unit's on fire.
That's exactly right. Every year in heat pump land, this thing is smoking. Of course, we have people that head from the New England area to the Floridian area, and some people don't make it all the way down there. They stop midway and say, this is pretty nice here in Wilmington. And every year those people call and say, this thing is smoking. Something is smoking on this thing. And, of course, we go, man, it's probably on fire. You're not, no, of course not. But we caution them. Of course, we you go out and check something because someone thinks something's on fire and you say, no, it's not. It's okay. That's not very comforting. You have to go check stuff. But a lot of times it's just defrost. In fact, every time it's been just defrost.
I've never actually seen a heat pump on fire. It's always been defrost. And for those of you who haven't seen a heat pump defrost in the wintertime, as soon as the fan shuts off and the outdoor unit starts getting heat into that coil, it starts making water vapor, and it's steam coming up out of the top of that heat pump. And it looks like the unit's on fire if you don't know what it is, because it looks like smoke coming out of the top of the unit. It really does.
And it's dramatic when it comes out of defrost because the fan will kick on, everything goes, whoosh, and then the reversing valve will hit at the same time, and you're like, okay, it's going to blow again or something.
It makes all kinds of racket. I mean, that's it, and it's a really good point to bring up too about locating a heat pump and making sure that it's not 6 feet away from the master bed.
I can vouch for that personally too. And if you do put one 6 foot from your master bed, make it not the Goodman CPLT model.
That's like experience.
That's what I had. The very first house I ever bought a long time ago came with it was a modular home, so it came with a Nordyne branded unit on it, and we replaced it with a 13 SEER, which at the time was the newest thing. It was 2006 or 7 where 13 SEER just came out. So Goodman created a CPRT and CPLT line. One of them was lifetime warranty, one of them was like a 5-year warranty or something like that. So I put this train outside of my, and I say train as in TRAIN, outside of my bathroom window in the master bath, and it was the single loudest thing I've ever experienced on Earth. And I've been to the airport, I've been to air shows, I've been to Civil War reenactments, and this was the loudest thing I've ever heard.
In the middle of the night.
In the middle, all the time in the middle of the night, because it's cold in the middle of the night, and it makes sense. But you'd be sitting there in bed, and all of a sudden, and I'm not doing that justice. Just imagine 115 decibels or whatever it was.
And that wall over here next to you just rattling and reverberating.
It's so hard to tell people that is normal, especially on certain series of units that didn't have the shifting and just, I don't know if it was the design of the unit or what. But the ones that do have the shifting, okay, let's get back to that. The ones that do have the quiet shift or that shut-off period, is the only purpose to that to make it more pleasing to the ear? Is there a secondary purpose at all?
To my knowledge, there's no secondary benefit to it. It is literally just to make it more pleasing. Now, it may be really good on the compressor too, because, I mean, if you have a compressor that sounds like that running all the time, chances are you're going to come back the next time and the compressor is going to be dead, in my experience anyhow. If I walked up on a unit that it sounded like that, I'd be like, you're going to be putting a new unit in this real quick. So it may be easier on the compressor. I've not seen any testing results, never been told about any testing results regarding that though.
I can sort of see that as maybe the difference between like a hard shut-off TXV with a start kit and having something like more free-flowing like a piston, and how it's easier on a compressor on restart if it's closer to equalize. I could see that being like a factor to that. I don't know if that's going to make much of a difference. I know it sounds horrible, and if something sounds horrible, typically something bad is happening. So
you should ask Don sometime.
Who's this Don? Who's Don?
Don Gillis?
Don, oh, yeah, we got Don in our group. Yeah. All right.
We should ask Don sometime.
So Don's a smart guy. I'll go find Don and bring him on here one day.
He works for Emerson, so, I mean, he ought to know something about compressors, I think.
Well, he should have mentioned that to me, or I would have been like, who's this Don guy that wants to share posts in my group? Decline. No, I'm just kidding. No, his posts always seem very educational, so I let him through.
Yeah, but, he's a really smart guy. He's one of the trainers over at Emerson.
Oh, man, I'm going to be contacting him tomorrow. All right. Well, thank you for that information. I didn't know he worked for Emerson.
Yeah. So, yeah, he does. I mean, he does all kinds of training, anywhere from compressors to CO2 training and everything. He's a really, really smart, knowledgeable guy. Very good guy.
I'm going to ruin his life. I'm going to be on him all the time. All right. Like Eric did it, or I'll blame David. How's that? I'll say, David Richardson told me about you. You want to come on 7 consecutive podcasts over the next 7 weeks?
Now you can totally blame that on me. Don and I are pretty good friends.
Oh, okay. All right. I see how it is. Okay.
I'll take that hit because I bet he'd love to be on here.
Oh, I bet most people are really excited about coming on doing this sort of thing, which is what I found, which is it's nice to know that people love their job and love whether it be, I don't know, whatever part of their job. I like psychometrics personally. I like that part of it. But people have it's fun. It's a lot of fun. I'm still trying to get Doug Lockhart. Doug Lockhart, one day, will get you on here. He's not watching. That was useless. So, all right, let's talk about time and temperature and then demand defrost. Let's start with the old trusty time and temperature defrost. Kind of describe what that is, and then we're going to compare it to demand defrost.
How far back do you want to go here? Do we want to talk about advancing timers with a screwdriver?
No advancing timers with a screwdriver. No vacuum switches or anything like that. We'll start like in 95.
So we're talking about little jumper pins and maybe some dip switches if you were lucky.
Yeah.
Those jumper pins often ended up on the ground in the mulch and never to be seen again.
This is true.
Saved them off of old boards in my truck.
Hey, I'm right there with you, man. I've gone to East Coast Metal and said, do you have any of the stupid black pins that I can have with me? And they say, yeah, we have a box of them over here. But absolutely, that was time and temperature. That's Goodman right there. For those of you who don't know what I'm talking about, I'm talking about Goodman boards. In fact, I'll put the board back up and you sort of continue with the description.
Yeah, you can see the little jumper pins over there kind of on the left-hand side of that board where it says 30, 60, 90 there. You had to jump the pins to, and then, of course, test.
Right.
But yeah, so time and temperature is basically the board has a timer in it, and it looks at accumulated runtime. And most of them either are 30, 60, 90. Some of them have 120 minute, and that's in minutes. So it looks for accumulated runtime. And when it hits that accumulated runtime, then it goes through a defrost cycle. And it has a sensor on the coil. So when the coil hits a certain temperature, it terminates that. And that's a Clixon style right there. What is that? Are those off a train maybe?
With the little end, the wiring tips on it there, I'm not sure, but it's very similar to the Goodman one, but they had little like stake-ons on the end of theirs. So I'm not sure which one that came off of.
But anyway, all that is a switch. It's just a temperature activated switch. And when the coil reaches temperature, it terminates the defrost and the board goes back through its cycle of reversing everything back into heating mode. So it's a pretty simple system. It has some drawbacks in it though, because it often does too many cycles. It can do not enough cycles. In most areas of the country, it does too many cycles and it defrosts too often, which wastes energy because it's not actually looking at what is happening to the frost on the coil. It's not figuring out where the frost is and how bad it's building up. It's just looking at that timer, and that timer is a guess, and it's kind of like load calculations, really, right? You set it up for the 5 days a year that it's at load conditions, and the rest of the time it's oversized.
Right. Absolutely. It's and that little temperature sensor, which was right here, it hits a certain temperature and it closes.
Mm-hmm.
And at certain temperature, I don't know exactly what the temperature is. I don't know. It's probably upper 20s or lower 30s.
Typically, it's about 60 to 70 degrees. I think it wants to see that coil at
when it comes out is what you're saying.
Yeah, when it comes out of it, correct.
So when it's going into defrost, when this thing, because the timer doesn't run until this thing tells it to run, correct?
Yeah, the timer is not, or it's not going to go into defrost until that timer tells it I've accumulated 90 minutes of runtime. It's a cumulative runtime. So if it has 91-minute cycles or it has one 90-minute cycle, when it hits the end of that 90 minutes, then it's going to go into defrost and run a defrost cycle until that sensor or until it warms the coil up enough to close that switch and tell the defrost board to switch back into heating mode.
Now, correct me if I'm wrong, but this sensor also tells the timer when to start. What temperature the line is tells it when to start, or is there a separate timer that does that? Now explain that to me, because I thought whenever there was a certain temperature of the air that it would start the timer.
That is on some defrost boards. Typically, that's going to be your demand defrost.
Right. Yeah, I've seen them on like the train units and stuff like that. Little thermistors.
So when you look at demand defrost, they look at the outdoor air temperature and the coil temperature, and they've got a thermistor on either on both places, and they look at the differential between those two. And when it hits a certain differential temperature, then it initiates a defrost. So it only defrosts when it needs to. So if you have a really dry climate or really dry weather where you're not accumulating frost on that coil, then it's not going to go into defrost mode.
But your time and temperature defrost is still going to run defrost every 30, 60, 90, or 120.
Yep.
And that's your main issue with it, I take then, because it's going to have those unnecessary defrosts, maybe constantly if you're in a really dry climate.
Yeah, I mean, if you're in a cold, dry climate, it might be defrosting all the time, every hour and a half. Well, you might not need it.
And let me ask you, we're talking about the timer on the time and temperature defrost. You set a system. You set a system up. You have this Goodman board, which to my knowledge, they still use a board just like this, and they have been since the dawn of dinosaurs. This very similar board, because Janitrol used it before them. It might have looked a little bit different, but it was pretty much the same thing. So, say you want to set it on the right number, 30, 60, or 90. How do you decide that? Or how do you get the best guess?
Honestly, everything I set up is 90. When I was setting those up, I just set up 90. I don't think I set anything up any less than that, because it just really didn't generally need it. I can't say it. I might have set a couple to 60 that had defrost issues on them.
Right, but you were compensating for maybe an issue that was occurring.
Yeah, possibly more than likely at the time. I was trying to compensate for something else that was occurring, and honestly didn't realize it at the time.
Yeah, I concur with your thought. I think 90 minutes was where we kept it all the time, unless they had it 120 minutes, and we choose 120 minutes. Even with a humid climate like this, it seemed like we never needed to go lower than 90.
Yeah, because realistically, what you have to think about is what is your temperature, what's your saturation temperature of that refrigerant in the outdoor coil, and what's the dew point of the air, because that's the point at where it starts condensing on there.
Oh, I need my psychometric chart now.
Or handy dandy psychometric phone calculator.
I should have that app. I don't have that app on my phone. I had, once I got the new phone, I didn't have the app anymore. I have a psychrometer somewhere.
Seriously?
That's embarrassing.
I use that psychometric app on my phone all the time.
Well, I just look unprepared. I should have just rattled off numbers like 67% humidity, 40 degrees is 30. But I know what you're saying, because that coil's cold. Then your dew point of the air, maybe it's 40 degrees outside, but the dew point might be 31 degrees or something like that. So
right.
You'll have issues there as far as accumulating frost. Okay.
If your dew point is below the saturation temperature of that refrigerant, you're not going to be able to accumulate frost on it, right?
Right, absolutely. Yeah. That's going to have to pass underneath it, which I think, I don't know what percent of the time you don't require a defrost when it happens, but especially in the early and late season, I'm guessing that's quite a bit.
Yeah, I find defrost happens a lot more in the mild temperatures, in kind of that 30 to 40 range, because that's typically where we'll go from a real high temperature with that has more humidity in it. Obviously, it's got a higher dew point, and then we just drop our sensible temperature down, and the relative humidity rises, of course, when that happens, and that's where you keep your dew points up a little bit. But when you get consistently cold outside, the air tends to lose quite a bit of its humidity, and we don't have nearly as high a dew point, so we don't get as many defrost cycles.
Okay, interesting. Okay, that's a cool point right there. Yeah, because we'll have these seasons when it's 65, and then it goes down to 30 something at night, and then it's relatively humid in the daytime, and then I guess the air is pretty much saturated by the time it gets down to 35. Oh, that's a good point.
Yeah, I mean, if you start watching your dew points, dew points are cool. they will tell you a lot about what's happening when you start looking at humidity with dew points instead of just looking at it with relative humidity, because relative is always relative to a dry bulb temperature.
I don't think anyone's ever said dew points are cool in the history of mankind till today on
I
this
don't
show.
know. Maybe not on this show.
No, half these guys in the chat
I
have
will
said
be
that.
the first. I will take that.
All these guys in the chat are just like this, and it might not be dew points. It might be, have you ever seen a blower door? They're awesome. That sort of thing.
Well, they are pretty cool.
I thought Steven Rogers, and I don't know if it's the guy that does the. Who does he work for? If it's the same guy, I do not remember.
I believe that's Stephen Rogers from the Energy Conservatory.
That's it. If that's the same guy, I don't know if it's the same Steven Rogers. I don't know if that's Captain America or Stephen Rogers from the Energy Conservatory. Either way, it's cool. So, yeah, either way, we'll take it. But, okay, let's come back to kind of jump back a little bit because there's something I wanted to go over because we talked about it before the show, and I thought it was really interesting, which is the dual fuel defrost cycle, because you have like either an furnace running off LP or natural gas, and you have it matched up with a heat pump. It initiates a defrost cycle. Take us through that cycle.
Okay, so that cycle is very similar to with a blower or an air handler and electric heat strips, except you're turning on a gas furnace. So what happens there is you have the blower running, and it's going to switch from over to a W call when the heat pump goes into defrost. So you're going to send W back to the furnace, right? At which time it's going to initiate a heat call. That turns the blower off, starts your inducer motor, goes through that cycle, starts the burners on, and then turns the blower back on. So you don't get that cold blow right away, but it dumps a bunch of heat right into that indoor coil, which is now your evaporator. So it dumps a bunch of heat into that and really fires out that defrost fast.
That was the cool part to me when you said the blower gets shut off. I kind of had it outside of my mind that whenever the heating cycle starts, obviously when a furnace starts, there's no blower until the heat exchanger warms up. I wasn't thinking about it like that. I was thinking about the cycle is running in heat. It's a heat pump, so the blower is going to continue. But I forget that I guess the IFC overrides the G call whenever that W1 or W2 or whatever comes into the furnace.
Well, and typically if you look at newer IFCs, they are using a Y call for their for their cooling fan speeds. We used to use a G call in the old PFC blowers. The newer ones, especially with the ECMs, are actually using a Y call, which is why we have to take Y to the board now, because they have a separate cooling speed, heating speed, and continuous fan speed.
That's a good point. And that's full variable speed blowers and X13 motors. I've seen like Train GAM 5s air handlers that'll have 2 or 3 different blower speeds. They'll have a constant fan speed or an optional constant fan speed. And that's relatively new. It never used to see that. It was just Y or just a G call and you had full bore fan. But now you can have like 2 or 3 different levels of fan, even on like constant torque motors, I guess, like X13.
Yeah, I mean, it's the evolution of the controls improving over time. Once we got these EC motors where we have a lot more control over our airspeed than we did with a PSC ever before, we can do a lot more stuff with this. And realistically, it's pretty inexpensive to build that into the boards, honestly.
Absolutely. Especially X13s, which are, I don't know, there's some, to me, they've always been trapped between the PSC style and the full variable speed, because X13 it kind of behaves like a PSC because it's single speeds, even though you can change them, but it's not quite.
It's a tap speed motor. Of course, it activates off low speed. And you're right, it is similar to the PSC because we set it up in the same way as a PSC. Typically, when we're doing our setup as it's new, you got to take your static pressure. You got to go back and look at the blower chart, pick out which speed tap you want to run on. But it's a lot more configurable than that PSC because the manufacturer can program whatever they want to in there.
That's true. I remember setting a few ASPF Goodman air handlers, and they're giving me the control to reconfigure the blower because something had happened during the setup process. So that is kind of cool. So it is kind of it's kind of an in between, but they have characteristics of both the higher end ECM motors and the PSC motors. I'm going to put it out there for the chat, folks, and that was Steven Rogers. He says he's both the Energy Conservatory and Captain America. which is just very cool. I feel like he might not be Captain America, but he's just saying that, but I'm not positive about that. But we'll take it, That's what I'm going to say tomorrow when I say, who watched the show? Captain America did.
Cool.
If you have any questions.
He's a pretty cool guy.
Yeah, now that he's in this chat, I don't know how he found his way to this chat. I don't know if you told him about this or he stumbled across it, but I'm coming for you too, Stephen, to be on this show. I just want you to know that. It's best just to agree to do it. I will be at your house every day until that day happens. So
I bet he would be happy to come on here with you.
I bet he would too. I've seen him do the webinars for TrueTech Tools, so it's really cool. So we need questions from the chat over there. If you guys have any questions, you want to type them in all caps because we are running out of time there. Here is my iWatch, not a Fitbit. It says 9:04. So we got about 5 or 10 minutes left here. So if you have any questions. Now, I think we explained the dual fuel defrost. Everything besides the initial, the IFC response to the call, like it's saying, turn off the blower. Everything else is the same throughout the rest of the cycle. So
the heat pump does it same. The heat pump does the exact same thing because it has no idea unless it's a communicating heat pump, and that's a totally different ball game now, because then you've got two-way communication between that indoor and outdoor unit.
Now that sounds like 60 more minutes of conversation right there. I
do
can
it.
tell. Let's just keep going. No, but okay, like an example of like a communicating heat pump, is it going to behave more like a mini split where it's going to have more intelligent, more intuition about what's going on in that particular cycle?
It should, but it really depends on how many sensors they have around the system, how it's programmed, because at that point you're talking about not just what I call relay logic or voltage logic. You're talking about communication logic, and you can do a lot more with that in a lot of cases if you have the appropriate sensors there. But whether or not they put the sensors in or whether or not they programmed it, who knows? There's a lot of different ways to do this stuff.
I'm writing that down. Next show.
You came out of this with about 5 more shows.
It always happens. That's why this is so sustainable. Now we'll talk. Let's maybe we can do a high-end defrost. We'll say high efficiency defrost version of this, because we could probably get into a lot more about the VRF stuff, mini split. Because say mini split and VRF like they're the exact same thing or something, but there's a wide variety in that area.
Oh man, that's a huge range. They, what did he just say? Yeah, one of the 3 coils without shutting off the heat to indoors, right? With a VRV, VRV, VRF. Of course, VRV is a trademark name, and VRF is everybody else. But yeah, they have like different sections of the coil on the outdoor unit that they can turn on and turn off, so you can defrost part of the coil at a time.
Oh man, see, yeah, the show's gonna happen. Let's do it in January, because we already got booked up for December and Christmas. I won't be here, and of course January 1st I won't be here. We're gonna record audio podcast for that. Eric, I'm gonna go ahead and say let's do it in January, man. Don't say no. Don't make this hard on yourself. All right,
Let's
good.
do it. Let's have some fun.
High level defrost. Sounds like it's some kind of covert program. The clandestine defrost process. Okay.
It's anytime you get into anything with a program, the software and the boards, and you can start throwing different logic at it, and if this happens over here, then we make this happen, or this happens and something else happens. Man, it can get crazy.
There's your narrative hook, everybody out there listening. That's your narrative hook. Stay on the line. Come back in January. I want to see some questions out here. We do have one. Weaver is asking, that's our buddy Dave Weaver, how are the heat pumps doing? How are the heat pumps doing in the north that claim they are efficient down to 0 degrees? Okay, well, it's going to kind of go along with that, because typically your inverter compressor heat pumps are the ones that say we can go down and heat well into -5 or something like that. So that's a kind of a general question. How are these heat pumps so successful where old unitary single capacity heat pumps were not?
Well, how are they successful? I mean, they work well. I mean, but how do they make them work? Magic.
You heard it here, Dave. Magic.
It's what somebody once told me, FM. And you figure out what the F is, and it's magic.
I got it. I got it right away. Well, whenever someone asks me that, what I imagine in my head is that they have these compressors that go up to even higher RPMs than standard cooling speed. I don't know how many RPMs, but they ramp up to compensate for that lower temperature. Am I in the ballpark?
They're running, 6,000-7,000 RPMs on the compressors. They're doing liquid injection to keep the compressors cool. They're doing all kinds of crazy stuff. And if you dive into the refrigerant circuit diagrams on some of these units, it honestly starts looking like the refrigerant diagram on a rack system in a grocery store. It's crazy.
We should talk about that too, then.
I am not a rack guy. Sorry.
Well, not the rack necessarily, but the just the VRF version of the conversation. We can find a rack guy. Any rack guys out there? There seem to be a lot of intellectuals in the chat tonight. One of you guys a rack guy? Find me a rack guy. Bring him in here. All right. Well, I think we
one or two. They're around out there.
I know there's ones. I think because of HVAC school, I think of maybe I can't remember if this name is right. Jeremy Smith. Maybe he's a rack guy.
Jeremy Smith is a top-notch rack guy. He is really smart.
Well, there you go, right there. And I know that I'm talking to a guy from Defrost, Jamie Kitchen, but I don't know how much he goes into that sort of thing.
I think Jamie's pretty good on the racks too. I know him. I've met him once or twice, but I don't really know him very well.
Man, life is
I've
good.
listened to some of his stuff. He's a pretty smart guy.
And I'll go ahead and mention, since I mentioned Jamie Kitchen will be on this show probably in January because, like I said, December's full. Next week, David Richardson back from NCI talking about combustion analysis. And then 2 weeks will be Paul from RLS to talk about what happened with RLS and Zoom Lock and Sporlan, which should be very interesting. As long as he'll answer all my questions. Should be very interesting. If he won't, then we'll never see that show come to fruition. But I think that those guys are frustrated. They want to get their story out, so we'll see. Eric.
Zach.
It's been a lot of fun. It's been we're going to make, like you said, 5 more shows out of this. That's what happens. That's why it's so fun to do this, because you say, well, speaking of that, let's talk about that for 60 to 90 minutes. And then you realize you have 12 hours of conversation slated. But I think we did good with a nice, simple defrost talk, kind of let everybody know how defrost works. There's a lot of people from other parts of the country not real familiar with heat pumps, a lot of people that just got into the trade. And I think about Jessica out there. I know Jessica just switched from maintenance maybe to service, so that's a good refresher for her, so it's kind of awesome. People at the beginning of their careers. So I want to thank you. Oh, I have your contact information. Let me not forget this awesome picture I made of you. If you want to contact Eric, there he is right there. So
call me Eric Bono Kaiser.
It's awesome. I had to put the glasses on you, then kind of dial it back a little bit so you can still see your face back there. It's skillfully done in the editor. It's maybe not centered perfectly, but don't look too close.
That is impressive.
So that's HVAC.Kaiser@gmail.com. And he will answer all your questions or ghost you depending on his mood that day. So I'm just kidding. He always answers. I'm just joking.
I answer pretty much everything.
He likes this stuff. Can't you tell? So, Eric.
It's a Friday night at 9:12 p.m. where I'm at, and we're talking HVAC, and I'm just having a blast. I mean, I love this industry.
Either we're a bunch of happy nerds or, I don't know. It doesn't matter. It doesn't matter what other people think. So That's what I say. And I could care less about other people. But I had a good time, and I really appreciate you coming on this first live stream with us. And, of course, it'll be a Shop Talk podcast here in a couple of weeks, so tune in for that. I just want to thank you, and I'm going to let you go here. And just want to say I look forward to talking again.
I appreciate you having me on, and I look forward to doing this again. And thanks, everybody, for coming by and, hanging out with us for an hour plus tonight and seeing what we can come up with to talk about.
Absolutely. We came up with 12 more shows, so the content's not going away anytime soon. And I just want to thank you again, Eric. I'm going to let you go, but we'll talk again real soon, okay?
Thanks, Zach. Night, everybody.
Take care, Eric. Bye. All right, guys. That was Eric Kaiser. Man, talk about a guy who knows a lot of stuff about a lot of different things. Very impressive. Guys, in the chat, I see a lot of people in the chat that I don't typically see, which is an awesome thing. I don't know how you guys heard about this show, but I'm glad that you did. Stephen Rogers, I look forward to talking to you in the future, maybe in the same environment. HVAC Grapevine, what's up? I don't know everybody's actual name that's in here. Some people use the avatars and another name, but I want to say thank you for watching this show. If you're one of these guys in this group of guys who has this knowledge and wants to get it out, you can always email me. My contact information is in the description of this podcast, but in the description of this show, later a podcast, it'll be in the description of both of those, and it's hvacshoptalk@gmail.com. I think we had a lot of fun here tonight. I'm going to play another little ad. We'll have a little talk for a couple more minutes, and then we'll get out of here, guys. But this is our boys at NAVAC. A lot of good vacuum pumps and stuff like that. We'll be right back after these messages. That sounded just like a commercial break, didn't it? The NP4 DLM cordless vacuum pump from NAVAC features a high-performance lithium battery capable of up to 1 hour of continuous running time. Weighing a scant 15.4 pounds, this unit is exceedingly efficient and for technicians, easy to carry and store. The NP4 DLM's twin-cylinder operation provides high vacuum down to 15 microns. To save 8% off this product when you purchase, go to TrueTechTools.com and use our Shop Talk discount code. Hey guys, don't remember, go to TrueTechTools.com. You use our Shop Talk discount code. Just use it up. Use it every day. Buy one tool a day for every day of the month. Makes us look really good. Makes us look really good to those guys. And they're really cool guys too. And actually, Bill Spone, he comes on this show periodically. We'll see him. He talks about everything from home performance to, he has a lot of knowledge, just how the tools work, because obviously he's worked at Bacharach, and I want to say Testo, but I'm positive about Bacharach. I think he's worked at Testo as well. You know, Jim Bergman's in the same building, so he'll be back, I'm sure, at some point to talk about the same sort of thing. We got a lot of guys on here. We got a lot of knowledge, and I am your conduit to the knowledge. I don't actually have the knowledge per se. I have like 50% of it. But these guys, 50. That's shooting high. I realize that. I have 25% of the knowledge, but my specialty is getting these guys on to talk to you and asking the right questions, and hopefully asking them in a way from a technician's point of view that gets you guys the knowledge the best way possible. Real quick, just make sure if you haven't subscribed to the channel and you enjoyed the show, please subscribe to the channel. Give the video a like, because that helps somehow on YouTube. I don't really investigate how this helps on YouTube. I probably should. I work real hard, but I don't investigate that. But give the video a like. Subscribe to the channel. If you want live notifications, in the description of the video, I have categorized all the different links. You should be able to find live notifications for whatever show you want to watch, whether it be this show or Skilled Trade Up, which is our game show where we ask trivia questions and give away tools, which you should definitely check out as well, Wednesday nights at 8 p.m. Had to think for a second. Show goes on for a while, guys. Get tired. Skilled Trade Up, the channel looks just like this when you go there. Obviously, this is an older picture of it. There's much more as far as videos on there. But if you just type in Skilled Trade Up on your YouTube search, you will find it. It will be there. That's Wednesday nights at 8 p.m. If you want to support the show, and it's a lot of times this is for Skilled Trade Up because I purchase a whole lot of tools and I ship them all out to you guys that win. So if you want to support the show for $1 a month or $5 a month, we really appreciate that because it makes a huge difference and it takes a lot of the load off me where I like to spend money on tools. Even if it's for the show, I enjoy it. So please help me out. Keep me out of the poorhouse. Thank you. HVAC Shop Talk podcast every week or 8 days or so, really, is how it seems to be coming out. We have a new podcast. We're going to have Tersh back on the podcast. You didn't get to see that in a live show because it got cut off a couple weeks ago. But Tersh is going to be talking about some more business stuff. He's going to be talking about surviving the winter as an HVAC business, what to do with your business, really because you want to make sure that you prepare in the summer for what's going to happen in the winter. That's really what he talks about. So that'll be coming out in a couple weeks. David Richardson will be back next week. We're going to have Paul from RLS after that. Jamie Kitchen's going to be on in January, most likely. That's not fine-tuned yet, but probably in January. Hopefully some of these fine guys in the chat will. You guys contact me. HVACshoptalk@gmail.com. Please hit me up. I would like to talk to you about coming on the show, different subjects we can talk about. Last look at the chat. Steve, am I late? Yes, you're late, Steve. You're way late. What are you doing? You're really late. Luke. Goodbye, Luke. We're about done for today. Goodbye, Clint. About done for today. I do have my Christmas tree up. That was a question in the chat. I do have my Christmas tree up. We enjoy Christmas here. We are wrapping up, getting our stockings for the soldiers, and that's over. Obviously, I'll put it up on the screen, but this is over. It ended at the end of November, but we had a great time getting those stockings together. There's probably 200 stockings. Before the show started here, before I ate dinner, we had these big boxes. I'm just filling them full of stockings. I've got 3 large moving boxes already full, and I think it's going to take about 10. And we're going to have to ship those bad boys, so it ought to be fun. But it was great. I hope, or I wish I could see the soldiers when they open these things up, and I hope it brightens their day, especially the ones that are far from home at Christmas time. And it's got to be really hard on the soul and hard on the heart to be far away, especially if you have family back home. I could not imagine, especially with 2-year-old Jackson running around in the house now after all these years of having only 3 kids. Bam, the 4th one happens. But I couldn't imagine not working like I do here on this show and the podcast and being out in the field 12 hours a day and not being able to watch him grow up like I can now. I'm so thankful for that. So when anyone is separated from their family like that, it hits me extra hard. And I'm just glad we can help take that sadness out of them, hopefully just a little bit, until they get back home. So that was kind of heavy right there. Let's end the show on a happy note, guys. Thanks for watching. We'll be back next Friday night with David Richardson. We'll be back on Wednesday night for Skilled Trade Up on that Skilled Trade Up channel. Again, look at the description for all the links there to find all the information you need to know about what I'm doing here personally. And I'm going to get out of here, guys. I really appreciate it. Thanks to everybody in the chat, and I will see you guys on the next one.